Till now, we know that electric current is flowing through the electric circuit, and that is because of the flow of electric charges. But I have a question. What makes the electric charge to flow? Why are they flowing? So now we will discuss why the electric charges flow. For that, let me give you an example from a day-to-day life. A ball is kept on the table. Is it at rest? Will it move on its own? No, right? When we apply an external force, then only it will move. For example, you are pushing the ball a little. What will happen? As a result, you will see that the ball is moving on the table, and when it reaches to the edge of the table, it will flow down. From this example, I won't say that the ball moves on its own, right? Here, I want you to keep in mind that the ball will start moving when it gets some trigger. Trigger means when it gets some external force. Then only it will start moving. Keep this much in mind. Let us take the next example. When a coffee filled in a coffee mug is hot, when you keep it on the table at room temperature for some time, what will happen? After some time, you will see that the coffee becomes colder than before. Why does it happen? It happens because the temperature of the coffee was more than the room temperature, so it was hot. And when it is kept on the table in the room aside for some times, what happens? It has more heat energy because it has more temperature than the room temperature. While on the other side, the room has lesser temperature. That means here we can see there is a difference of temperature, right? The temperature of coffee and the temperature of room, that has difference. So what will happen? As a result, the heat energy from the coffee will start moving to the room. That means the heat energy from the coffee will move towards the atmosphere. We have already learned that the energy will flow from higher region of concentration to lower region of concentration. Higher region in this case, that is the hot coffee, and lower region of concentration, that is room temperature. So the heat energy will move from coffee to the room, and that is why after some times the coffee will lose its heat energy and it will become colder. So when this happened, when there was a difference between two temperatures. Now let us talk about our topic. This is a copper wire. When can this copper wire have the flow? The earlier two examples which I gave, in that we saw there was a difference. That is why it gave rises to flow of something. Here, when there is a copper wire, what will lead it to flow? I guess you have answer. When there is a change, or else when there is a difference between 2 points, then only it will lead to flow of charges. For example, this is a copper wire and there will be two ends of this copper wire. So when there is a difference between these 2 points, then only the electric charges will move from one point to another point. Is it clear to you all? When there is a difference between the 2 points, then only the electric charge will move from one point to another point. So for electric circuits, what will be the difference? So there will be the difference in electric pressure. What it is? It is the difference between electric pressure. And that difference in electric pressure is called as potential difference. What it is called? Potential difference. So when there is a difference of potential between two ends of a wire, then there will be flow of electric charges. They are the flow of electrons. Now, this much you know, that when there will be flow of electrons, it is the reason that they have difference in electric pressure. But who will generate this difference in potential? Who will generate this difference in electric pressure? We have answer for that. A cell generates electric pressure in between two terminals. You all have seen this kind of cells, right? On which it is clearly shown positive and negative signs. These signs are for what? These signs show that there will be positive terminal as well as negative terminal. So this creates potential difference, or else we can say that electric pressure in the circuit. When this type of cell is connected to an electric circuit, and when we switch on, this cell will generate potential difference between the two ends of a wire. So this is the use of a cell. What is this? To generate potential difference between the two ends of a wire. Now there is a difference between a cell and a battery. Okay, remember, a cell is this way, single one. And when too many cells are connected with each other, then it makes a battery. Remember this much. So, the chemical reactions within the cell will generate potential difference. Now, let us learn the definition of electric potential difference. The electric potential difference between the 2 points in an electric circuit carrying some current as the work done to move a unit charge from one point to another point. In simple words, we can say that electric potential difference between the 2 points is the work done to move one charge from one point to another point. Okay, so remember what it is: work done to move a charge from one point, or you can say one place to another place, or else one point to another point. So it can be written in terms of formula V is equal to W divided by Q, which is potential difference between 2 points, that is V. The symbol of potential difference is capital V. Work done, that is W, and charge, that is Q. The SI unit of electric potential difference is volt, VOLT, volt. Now, keeping this equation in mind, V is equal to W divided by Q, we can define what is the meaning of 1 volt. 1 volt means the 1 volt potential difference between 2 points in a current carrying conductor when 1 joule of work is done to move 1 coulomb charge from one point to another point. See, if we are defining 1 volt, that means in the formula everywhere to keep 1 potential difference is equal to 1 joule of work divided by 1 coulomb of charge. Simple. Therefore, we can write it as 1 volt is equal to 1 joule divided by 1 coulomb. As I said you, everywhere to keep 1, then we can define easily 1 volt. The potential difference is measured by means of an instrument called the voltmeter. Students, this difference you need to remember. Electric current is measured by ammeter. Potential difference is measured by the voltmeter. The voltmeter is always connected in parallel across the points between which the potential difference is to be measured. Keep in mind, always voltmeter will be connected in parallel. Do you remember what about ammeter? Ammeter is always connected in series, whereas voltmeter is always connected in parallel. Why is it so? Because we have to find difference between any 2 points. So wherever we have to find potential difference between that 2 points, we will attach this voltmeter in parallel. So this much is about today's session. Thank you.